All right, scholars, time for another thrilling installment in Module 2 Notes. Go ahead and make sure you have your name and your number in the upper right-hand corner. Module 2 Notes right here. Today we're going to talk about Lesson 2-5. 2-5. So let's get that Roman numeral V, Roman numeral 5 in there. There we go. 2-5. We're going to talk about some things we've done before, a little bit on something we touched on in Module 1. We're going to practice how to use the area model. And this is a long title. Use the area model and standard algorithm. There we are. Algorithm to multiply. The standard algorithm, that's the way you're usually going to multiply. That's the way your families probably show you how to multiply. And again, it's standard. It's the usual one for a reason. But we're going to talk about the area model a little more because the area model helps show why the standard algorithm works. It also, this sounds odd, but once you get the hang of the area model, for some smaller multiplication problems, the area model can actually help you do it mentally. Now, we're going to dive right into procedure this time. Most of the vocabulary, talking about products and factors, we've discussed already. So, let's dive right in. Procedure, the area model. Now again, you've seen a little bit of this already, so hopefully it'll look semi-familiar. Okay? First thing you're going to do, step 1. Step 1. You're going to write the factors. Again, factors are the numbers we're multiplying together. Write the factors in expanded form. Now again, a more advanced way, you can write them basically any way you want to break them apart, but please stick to expanded form for right now. Expanded form, I think, is the most straightforward, and expanded form is essentially what's happening with the standard algorithm. So let's say I'm multiplying something like 25 times 31. For 25 times 31, I'm going to break each of these numbers into expanded form. So I'm going to separate the 25 into the sum of 20 and 5. Okay. 20 plus 5, it's in parentheses because this value is 25. It's one number. Okay. Looks like 2, okay, but it's really 1. And we'll do the same thing over here. 3 tens plus 1, 1. Okay. All right, so there it is in expanded form. Number 2. I'll skip a line to kind of keep this clean so you can see what's going on. For step 2, we're going to draw a rectangle. Draw a rectangle. This is again where the area model gets its name. We're going to find the area of this rectangle. Draw a rectangle. Label it with the factors. Label it with the factors and break it into pieces. Break it into pieces. We're going to break it. All right, let's see what that looks like. Okay. Now again, this does not have to be a perfect rectangle. It is just a quick sketch. So as much as I want to get a straight edge out and make this look perfect, we're not doing that. If you're like me and you would still like it a little more perfect, I usually find I get the best results when I'm pulling my pencil down, so I turn my paper. But again, that's just me being kind of silly. There's my rectangle. Okay, now label it with the factors, specifically the factors in expanded form. So I'm going to put 20 plus 5 up here. Commutative property says it doesn't really matter which one goes first. It doesn't really matter which one goes on top. That was first. I made that first, so I'll do this first, but it really doesn't matter. 30 plus 1. 30 gets one line of its own, plus 1. Okay. Now to break it into pieces, I use the plus signs to help me. I draw a line straight down from that plus. I'll draw another line straight out from that plus. Again, I just turn my paper sideways. It helps me keep the lines a little straighter. Okay. All right. Now for step 3, we've got our box, we have our rectangle. It's labeled and broken up. We're going to multiply each part of the factors. Multiply each part of the factors. Okay. Now, part is pretty important here. Okay. Part is pretty important here because when I wrote the factors in expanded form, I was breaking them into pieces that would be easier for me to deal with. Easier for me to multiply, like I said, mentally, although we're still going to write it on paper so we can see what we're doing. The biggest thing we need to multiply is 30 times 20. It's like a multiplication chart. You see where the two meet. See, 30 goes across, 20 comes down. They meet in this box. This is the most complicated one we're going to do, and because they both end with 0, it's not all that complicated. 3 times 2 is 6. We've practiced that a few times. 1, 2 zeros. 1, 2. Okay. 30 going all the way across, lining up with 5, so 30 times 5. Once again, 3 times 5, 15. Just add the 0. Okay. This line's even better. 1 times 20. My goodness, I wonder. And then finally 1 times 5, 1 going across, 5 coming down. Okay. So there we go. Now, once I've multiplied each part of the factors, step 4, we're going to add the products from each box. Add the products. This is going to be weird, but I'm going to go down the next line. I'll show you why in a moment. Add the products from each box. Is basically what we're going to do. We're going to look at this box, look at the rectangle. We had 600, 150, right? 30 times 20 is 600. 30 times 5 is 150. If I add the 600 and the 150, 600 plus 150, that would be 750. And if I add these across the bottom, 20 plus 5, right? This is a partial product, a part of the product, 20 and 5. Then I get two numbers that are super easy to add together. Okay, 750 plus 25. We'll make sure we line those up correctly so we got the 1s, the 10s, right? Go ahead and add them together. Some of you have already done this. 775. Okay. Now again, I could do a slightly longer way. I can just add each part. 600, 150, 20, 5. You can do this however it makes sense to you. 0 plus 0 plus 0 plus 5 is 5. 0 plus 5 is 5. Plus 2 more would be 7. 6 plus 1 is 7. So I get the same answer either way. Again, I kind of like this just because if you can mentally add these two together, then you just have two things to add. Many of you probably can do that mentally too. Okay. It's a little weird for me to constantly be suggesting that we do so much of this mentally, but sometimes it's nice to be able to do that. You can see we still are writing some things down so we have proof of our work. We can show what we're doing, and if there's a problem, we can go back and figure out where that problem is. Now, that's the area model. Okay? You take your numbers, your factors, break them into expanded form, put them around this rectangle, multiply to get an answer in each box, and then combine all those together. Now, I told you in the beginning that this is basically here to explain, one, it's how to do it kind of quickly in your head with smaller numbers, but it's also to explain why the standard algorithm works. Why the standard algorithm. I'm sorry, I always have to sound that out. My spelling is not the best. The standard algorithm works. Okay. So let's take a look at what the standard algorithm is. And this is basically the multiplication that you learned in 4th grade. Okay? So step 1, we're going to write the factors. There's our friend, the factors. Write the factors vertically. Okay? When we're using the standard algorithm for addition, subtraction, multiplication, vertically. Now, I am going to use the exact same numbers, so you already know what this answer is going to be. That's not the point. It's going to be 775, at least if I do it correctly. I want you to watch how it works and how it matches up with the area model. Okay, so let's go ahead and draw one of my wiggly arrows. Okay, 31 times 25. Now, you want to line them up very carefully. Line them up carefully. Okay. Line them up carefully. You always want them, now, well, you want all the numbers lined up on the right-hand side. We'll talk more about that as we get further into it. Okay. Now for step 2, and don't worry, I'm not going to make you do that again. We'll continue on that this particular example, because if you're like me, you're probably running out of paper. Let's go ahead for step 2. Adjust the camera a little bit. For step 2, start at the right. That's why we have to line them up so carefully. Start at the right. Start at the right. And multiply, moving to the left. Okay, actually, that's an exclamation mark. That's pretty important. We're going to move to the left. Now, one thing I like to talk about with students when we multiply with the standard algorithm. Okay, we start on the right. I said that down here. I like to circle this and say, this is our focus number. This is the first thing we're multiplying. And I'm going to ignore that. Okay? I'm going to ignore that. It's just 5 times 31 right now. Okay. 5 times 1 is 5. Wait a minute. That's interesting. 5 times 3. Now I'm going to say 5 times 3. Here's our focus number, 5 times 3. This one right here, 5 times 3. And I'll say that's 15, but really 5 times, that's a 3 in the tens place. 5 times 3 tens. 5 times 30 is 150. 150 plus 5 is 155. How interesting. Okay. Now, when I'm done with my first focus number, I'm going to go ahead. I'm going to lightly draw some lines through it to show that I'm finished. I'm not erasing. I am not scratching it out so it's so black you can't see anything. Just scratching it out a little bit. Okay? Because now I have a new focus number. And again, I'm going to read this as 2, but it's not really 2, is it? It's 2 in the tens place. It's 2 tens. So 2 tens times 1. 2 tens times 1, 20 times 1, 2 tens times 1 is going to be 20. Okay. Now as we get further in, we're going to talk, you're almost always, well, you are always when you go into a tens column like this. You're going to have what I call the spacer 0, but we'll get to that later. 2 tens times 1 would be 20. 2 tens times 3 tens. Again, I'm just going to say 2 times 3 is 6. But again, 2 tens times 3 tens is 600. 2 tens times 1. 20 times 1 was 20. Combine the two together, 600 plus 20, there's 620. The area model is showing you in a very broken apart way why the standard algorithm works. This is what you're going to do most of the time because this is faster and it takes up less paper. But the reason it works is because really what we're doing is we're breaking things apart into expanded form, multiplying the different pieces together, and then reassembling the pieces. Okay, this builds off the distributive property we talked about previously. Let's wrap this thing up. Okay, for step 3. Step 3. And again, if you're like me, you're probably at the bottom of your page by now. Maybe you've gone on to the next page. Okay, for step 3, we are going to add to get the final product. Add to get the final product. And I don't think I need to warn you, it's going to be exactly what we already had up here. 5 plus nothing is 5. 5 plus 2 is 7. 1 plus 6 is also 7. Hey, that certainly looks familiar. Okay. Now, we're going to wrap up. The area model is important for a number of reasons. Again, primarily to show you why the standard algorithm is working, and to give you an understanding of how we're taking partial products, part of the product, and combining them to get our final answer. But most of the time you're going to use the standard algorithm. When I test you, you're probably going to use the standard algorithm, although you'll probably see 1 or 2 of these to complete as well, just again, to show your understanding of this strategy, of this method. All right, I think that needs to be it for now. As always, if you have any other questions, please let me know during class. I will see you then. Thanks, everybody.